As discussed previously, using client-side encryption allows the application to encrypt data prior to sending it to disk or other persistent cloud storage. In many cases, client-side encryption may not be required. However, regardless of your choice to use client-side encryption, as a best practice, we want to ensure that data stored in the cloud should at minimum make use of the cloud provider's server-side encryption capabilities. S3 buckets provisioned in AWS support a few different methods of ensuring your data is encrypted when physically being stored on disk. The first method is server-side encryption with S3 managed keys. With this, we can specify that an object written to S3 will be encrypted by S3, and the S3 service will manage the encryption keys behind the scenes. Because the key management aspect is transparent to the caller, this is the simplest and easiest option. It is important to keep in mind that with this option, anyone with read access permissions to the bucket and file will be able to make calls to the service to retrieve the file unencrypted. The second method is server-side encryption with AWS managed master keys stored in KMS. With this option, the caller will need to specify that KMS will be managing encryption keys for the S3 service. Keys are provisioned in KMS automatically when this option is used. This also provides additional auditability of S3's use of the encryption keys. The third method is server-side encryption with customer-managed master keys stored in KMS. Here, the caller will also need to specify the key that will be used for encryption. Additionally, the caller needs to have permissions to use the key. This provides additional ability to control and restrict which principals can access or decrypt sensitive data. The last method of doing server-side encryption is with customer-provided keys. In this case, the customer can provide their own encryption keys to S3, and S3 will perform the encryption on the server side without keeping the key itself. The key would then be provided with the request to decrypt the object. With this option, the burden of managing the keys falls on the customer. All of these options can be implemented in two ways. Encrypt on write of object API calls to S3 for uploading or copying file objects will need to explicitly specify the type of server-side encryption desired. The application code will need to be aware of the desired server-side encryption setting that is chosen. Enable default object encryption in the S3 bucket configuration. This will automatically encrypt files that are written to S3. Default encryption will allow you to specify which type of server-side encryption will be used and designate a specific KMS key if you choose to do so. In this case, because the setting is enabled at the S3 bucket configuration level, the application code doesn't need to be aware of the type of encryption that is being used. To review, server-side encryption for AWS services is a very powerful and transparent way to ensure that security best practices are implemented. We have highlighted this with S3. However, other AWS services, for example DynamoDB, also provide this functionality.